Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
To round out this action-packed mobile computing interest track, I know that a lot of you have been through a large percentage of the sessions. We thought that it would be important as kind of a final step. So you've seen a pretty wide range. You've seen some on Windows Mobile. You've seen a couple of sessions on shrinking Windows machines. And then, of course, a couple of user interface explorations. And I thought a nice session to really tie things up would be to talk about this phenomenon that mobile devices and mobile computing in general is really becoming a wide landscape. There's a lot of different classes of devices. There's dedicated single-purpose devices, general-purpose devices. Of course, all of these at some point hook into the PC on the back end. It's really become a very thriving ecosystem. So what this session is about is this concept of extending computing. How can a wide variety of special-purpose and general-purpose devices kind of work together with a PC to create a computing ecosystem? So that's kind of the theme of this session. To build that session, we have three very different presenters. The first one is Jian Wang in town from MSR China, who actually just arrived, so we're thankful to have him here. He's going to talk about his UPenn project, a very, very cool, ambitious, intelligent pen computing project. Then we're going to transition over, and Steve Glenner from MSR Redmond is going to talk about some of the projects that he's been working on that pull a phone together with a PC to think about how they can work in interesting ways. And then a sort of a bold visionary close both to this session and to the mobility track. We're fortunate to have Brad Myers from Carnegie Mellon HCI Institute to talk about future research directions and kind of what is the research problem with regard to distributed devices with different general purpose and single purpose features. So it should be a pretty interesting session. We're covering a lot of topics, and we should allow some time at the end for an open dialogue with you. So first we'll start with Jian Wang from MSR Asia.
Thank you, John. It works? Hello? Hello? I'll probably just use this one. Is it okay? Just use this one. Okay. Good afternoon, everyone. And I'm happy that I have this opportunity to present some of the work we're doing at Microsoft Research Asia. And my talk today would be talking about how we could reinvent the printed document to make sure that make the print document digital. And here's the outline of my presentation. So basically, I'm going to talk about the challenge and approach first, and I'm going to present some of the technology that we developed in the lab. And finally, I'm going to talk about the software and hardware architecture that we built around this technology. And we have spent about 10 minutes to do the demo that based on these technologies. The first thing I want to talk about is really today is the biggest challenge for the PC. I would say is still the non-digital way of doing things. So people still do a lot of things with in a non-digital way, like paper and pencil is a very typical example. And at the same time, PC create a lot of digital document. At the same time, the PC still create a lot of non-digital document. So printer actually attached to the PC basically convert a digital document into the non-digital one. So any print document today, it's basically is the non-digital document. And this is actually one of the problems that we are trying to solve for the UPenn project. It actually doesn't work quite well. It works? Yeah. Hello? Okay. Yeah. And the third challenge we have is really keyboard and mouse confine people to the desktop. So if we need a true mobility, we really need a better display that's much more mobile, and it needs a more mobile interaction device. So we think that the print document is really a good mobile display, and the pen is a good mobile interaction device. So our goal is pretty simple. Thinking about today, everything is probably digital document, is digital. So we create a document from our PC, and that's a typical today. And the way that we want to keep digital as digital is pretty challenging. And the first thing we're trying to do is that is there any way that we can make every print document digital? That's I think that is one of the challenges we have for this project. And as soon as have this print document having a digital property, then I think we can bring the digital computing to the places where today where the places that the things are still being done in a non-digital way. The approach we take to solve this problem probably is three interesting things. One is we need to develop a system, what we call the EIC system. Basically, it means embedded interaction code. So we are trying to develop the software and a coding system to make sure that every print document could be is interactive. And the first thing that we do is really provide a high density data embedding system. So we could provide up to the 192 bits for the addressing space for the document. And the second thing is more related to usability. As soon as you have this document printed, you must make sure that people still will not read as a regular printed document. So we have the family of visual design pattern to be used together with this coding system. So make sure that every print document is pretty much like a regular print document. Its usability is still acceptable for the reading and for the annotation and for some other purpose. And finally, since that we want to make sure that it's a kind of digital document. So what we can do with a pen is more than just write some ink on that. And we are trying to make sure that you can retrieve that document, and you can associate that document with the digital one. So having a multiple channel of embedded data actually the key for this purpose. And this actually just giving a general idea of what we did with that. So basically, we have the pattern, what we call the EIC pattern, that to help the pen interact with the paper. So this pattern basically is an array of 1 and 0. And we pick up a family of a visual representation of this 1 of 0. This is just one example. We just used a horizontal bar to represent the 0 and the vertical bar to represent 1 for this specific cases. Basically, we have the family of this visual representation of that. If you replace all these, replace the area of 0, 1 with this short bar, and you basically got the pattern of that on the surface. So with this pattern, you basically allow you to access every unique position on the print document. And the way we organize this sequence is based on a pseudo-random sequence we call the M-array. M-array actually are the M-sequence. M-sequence is a very interesting property called Windows property. What Windows property mean is if you have a polynomial like I show over here, this is actually at the order of 6. If you have the sequence like this and generated by the M-sequence, so what you can find is if in a window, that window size is 6, and you move the windows along to a different place, you can see that every window has a unique combination of 0 and 1. So by looking at that window, you can uniquely identify where the window is. So what we did is just extend this M sequence to what we call M-array. So we based on this one-dimensional sequence that with Windows property, and we found a way to generate a 2D array, and the 2D array actually is folded together. The reason that we choose the fold like this way is we want to make sure after the sequence fold into two-dimensional array, it still keep the property, the Windows property for this two-dimensional array. So when they return the M sequence to M-array, we still keep the Windows property unchanged. So that still giving us the unique decodability over the two-dimensional space. So that's actually the thing that behind the EIC pattern. In terms of data embedding, as soon as I have this M-array, we basically have to decide, okay, what kind of data we want to embed for that array. So we basically have 3 different data. One is very typical for the inking. That called we just have an XY coordinate embedded anywhere on the space, and the second is much more like a global metadata. And the one important metadata for the print document is a unique document ID. So basically, you can embed the unique data all over the document. And for some special purpose, you might just want to embed some local metadata on a specific part of the document. So you still have no way to do that. So we provide a mechanism so you can really choose these three different types of data to work together with your digital document and print out. So basically, you have different channels of data, and you can use for your document. And the other challenge is really how to combine this information with your original digital document. So you have to find a way to binding the EIC with the document. And this is just an example that how we bind it. We could know whether it's a graphics picture or whether there's an action button on there or whether it's just a text of there. So we can keep track of the layout and all the text information over this printout document. And this is the hardware we built for reading that system. So basically, the ERC system can be read by any device. But we basically think, OK, pen is really a primary device to read that. So we built this the pen prototype and had a very small optical system and a pretty good electronic system, including the processor. And we just have a recent prototype and have the Windows CE 5.0 running on that. And so it's basically a pen computer. It's more than just a dummy stylus or just a pen. And we're pretty happy that with the result we get from this pen and this EIC system. And so if you compare the data we get from the system, it's pretty comparable with what tablet PC can do today. So in terms of the data resolution, so pretty high. It's about 400 dpi, so it's meet the minimum requirement of tablet PC. And also in terms of the spatial resolution, also it's very close. It has is similar to a tablet PC, so more than 100 hertz. So basically, the data we get from this print document plus the pen is similar to what the tablet PC have today. So we can leverage the platform that we already built for the tablet PC. So all the software that we built for tablet PC today can be used by the system we are building here. And also, we are pretty happy with the precision of the system. And you just need the caliber once for the pen when you build that. And the extra position is pretty high. Actually, if you compare with the stylus for tablet PC, actually the accuracy is actually higher than the tablet PC stylus. And this actually here is just to show you how the camera that built into the pen can see. And actually, the unique technology for this ERC pattern is really the pen can see both the content of the document and the code that be embedded into that document. So this actually is a typical image that you can see from by the pen camera. Actually, this is the prototype that we use a tiny camera that only has 32 by 32 pixel, and this is our first prototype. And the prototype we show you today is actually have 100 by 100 pixel in terms of the camera resolution. So basically, you can see the document content, you can see the ERC pattern, and you can see some of the background area. So what we first do is really do a segmentation, so we can know which part is the code, and which part is just the background. And as soon as I have this segmentation done, and you have to process the pattern grid. So the first thing that we did is really we should know that which part is really the pattern grid, and then have to decide the orientation of the pattern, because when we use the print document with the pen, you actually rotate it in any direction you want. And so you have to decide the orientation of the pattern. And finally, based on the pattern, you have to know that the value of each bits that you got for that. So basically, from that single snapshot of the image, and we are trying to retrieve about 192 bits from that. And when you got the XY coordinate from the bits itself, it's still not precise enough for you to get the exactly the XY coordinate for the tip of pen. So you have to kind of fast the image matching on that. So this is what we did. You got the original image, and you have from that grid that have the basic transformation from that image, and you can do a transform a little bit and make sure that the map back to transform the center of the camera to the tip of the pen, so you can get exact XY coordinate of that. This is actually the SDK that we built for the system. So what we built basically two parts. One is the PC part that's on your right side, and that's actually help you to print the document and build the application and the process the metadata information. And we also have some of the software that we specially built for the hardware. So you could put most of software on your pen for that. So the right side is really for software on PC, and the left side is a framework that could be running on the pen itself. And so that's pretty much my presentation. And I'm happy to show you some of the demo that we have. The first demo that I want to show you is about the annotation on the printed Word document. So this actually is a Word document. It's a pretty long document. It's about 20 or 30 pages. And let's see if we can. Here we go. Yeah, this is a very typical Word document. Actually, it's a Marcos document, and try to understand why people print document. So what we can do is we can pick up any document, any pages of document. Like right now, I pick up the first page of document, and this is the prototype that we have. So what I'm trying to do is over here, and I could write an underline on that. So I underline this one. And you can see that even without telling that which document I'm working on that, and basically the system looking for that document based on the ID and open that document for me. And I'm sorry, I should switch to my PC, having a laptop over here. You can see that. So that's actually the document I'm just working on that. Okay, let me switch back and forth. So yeah, this is just I just write on the print document, and let's switch it back over here. So what I'm showing you is over here is not just an image on top of your print document. It's a live, what we call the live ink or digital ink on that. So what I want to show you right now is if you do a processing of this ink. So basically, you can identify as an underline. So if you change the layout of your document, actually the ink is going to reflow with the document automatically for you. So you can see that the ink keep track of your document when you change the layout. So that's actually the live ink. It's not just an ink on top of your image. So that's why we said, okay, we actually make the print document in some kind of a digital property. So that's the first thing that I will show you. So basically, you can pick up any document you want. So let's see. Okay, I could pick up any page of this document, and let me switch back on I'm sorry for that. And you can mark on that document anywhere you want. So I could just mark a document. Okay, this is a non-standard reading interface. So I could mark it over here. And if you switch back to PC, you can see that they locate that page and put the annotation on there. So this is one of the demo that I want to show. And secondly, we really want to show you the power of the printed document. So thinking about the presentation, and you have a lot of different ways to do presentation. I think a lot of people really print out the PowerPoint slide like this. So what we can do is, if we have the PowerPoint printout like this, you basically do a couple of things. One is you have to wait to help you to do the presentation. And the second thing is you could do the annotation anytime on your slides during your presentation. And you might want to do some private note-taking on this printout as well. So we are allowed to do that. So basically, you can, with this printout, you can allow you to control your presentation and take your notes in a way that's most convenient for you. So what I'm trying to do is, let's see, I'll switch back to this. So this is a very typical printout of that. So if you want to go to like slide number 6, as I show here, so what you do is just click, just check a number over here, and the system takes to you that slide. And this is actually is much more convenient than even a laptop. You have to go through the slides sequentially when you do the presentation. But with this, you basically could go. Oops, let's see. Yeah, I'm sorry, I have to see that one first. Yeah, you can see that I basically take that slide to that one, and I could check on again, and you can switch it back and forth. And so that's a pretty easier for the presentation. So if you're thinking about if you want to take some notes, you basically can write the notes over here. And I'm sorry, I have to switch it back and forth for a while. And you can see that actually all the notes is in a notes area in your PowerPoint presentation. So we hope that it's the other way that the pen can augmented by the printed document, and it helps you do the thing that today you normally do in a non-digital way. And the second demo that I want to show you is it's a fun project. And thinking about you have the music sheet like this. Okay. So this basically it's a music sheet. So basically you can print out a sheet like this, we call the music sheet. And I'm sorry, I'll probably let you see that. You can use a pen to write some music on that. I'm not a good musician, so I'm going to pretend to be a good musician and just write something on that. So I just put some notes on there. If you go back to our PC, oops. Actually, the notes is there, and the power of the PC is really you can play that notes. So again, this is a live ink. It's not an image on top of the image. And actually, we could use this. We can use this system to write something that's pretty fancy. I just want to show you. That's actually done by one of my colleagues in Beijing. So you basically can write the music like this, and you can play it again. So this is we talked with some musicians. They saw that to write music with pen and paper is more natural and a creative way for them to compose that music. So the next thing that I want to show you is more technical. So we just have the tablet PC group to ship the probably first handwriting math equation recognizer. It's going to be out in the next week. So what we can do with that, we take that, we actually use the math recognizer we developed and combine with this, the pen system. So what I'm trying to do is, I'm trying to print out what we call the equation sheet, okay? So you can write you can write they already have the two equations on that, so I'm just writing a very simple one. So basically, you can write an equation like you can write an equation like this, and it is in a computer automatically. Okay, this actually is what I'm looking at, and if you go back to the PC, and you actually see that the equation is there. So you can go. You can let the program to call the math recognize and do the recognition. So again, this just shows you that the ink is the exact same as the ink we can capture from the tablet PC. And you can leverage all the platform that we have today to do other things. That's pretty much the demo in terms of the Office document. And I think one challenge that one thing we want to push for the envelope of this for this technology is print out a CAD design like this. So all the paper you print out like this size. So basically you can print out. Could you help me to do the demo again? Yeah, could you help me to do the demo? Yeah, basically I asked the Chunhui to help me to do this demo. It's a large sheet of that. So basically you can print out like this a CAD design, and you can use the same software to make this software to work with the AutoCAD. Okay, so you can use this for the design discussion or whatever you want. So what the Chunhui is going to show you is we launched an AutoCAD, and we developed a plug-in based on the SDK we built for the AutoCAD, and as soon as connect this with the pen, and then you can do anything with this print out design, and with the pen. Okay, it works. Yeah. So we actually have the other thing I have to ask Chunhui, because you can do this in a collaborative environment. So you can print out two of them. Okay. So this is a small copy of this design, and this is the large one. And you can work on any of them, and the system knows that which document they're working on that, and they could show you that on the same screen. Yeah, right now he just ran on this, and it's open that. Okay, open that document for you. You probably right there. Okay, yeah, I can see that he just drawn a circle in the area over there. And what I'm trying to do is I'm trying to write something else on this large printout, and hope it still works. Okay. So let me see. Yeah, this actually is what I'm trying to do over here. So hopefully that with this software, and in the future, that every print document is digital, that can talk with the PC and a small smart device, so that people could do a lot of things that today that is still doing in a non-digital way. Okay, that's actually my demo and my presentation. Thank you. Yeah.
General Q&A at the end, as typical. Next, I'd like to introduce Steve Blenner from MSR Redmond, who will be showing an app on the smartphone via the document camera. Yeah, that's fine.
That's a big phone, huh? Is there an iris control for this? there an iris control for this document camera? There's a control here for that. Well, all right, maybe I'll be all right. Hi, my name is Steve Glenner, and I'm with the Next Media Group in Microsoft Research, and we try and build interesting experiences for users to access their media. And this particular project is one that I started because I have a digital photo library at my house on my home computer that has about 10,000 items in it, and I wanted to be able to access that photo collection basically from my phone wherever I am without having to pre-synchronize items onto the telephone. So, you know, there's really, thanks. Is that better? Maybe. The phone that I'm using here is just an off-the-shelf Motorola MPX 220, which is running Windows Mobile 2003. And I have a small application that I'm running on my home computer that serves up these images. And basically, I've already connected up, and I can just pick an image. It starts out showing me my favorites initially. And you can see that it loads pretty quickly. That's because the display, when the phone connects up to the home computer, it negotiates the size of the display and the image quality that I'd like to see. And then the home computer actually rescales the image and recompresses it on the fly right before sending it to the phone. So even though this might be like a 3 or a 5 megapixel image and would typically take about 20 minutes to transmit over a GSM connection, it shows up in just a couple of seconds because when it's recompressed at this resolution, it only is about 8 kilobytes. And I can pretty much, you know, step through the images in that particular query. You'll notice that this particular image, there's a little speaker icon that lit up in the lower corner. And that tells me that there's a voice annotation that's associated with this photo. Because I'm using a telephone to access collection, it has a microphone, it has a speaker. So I can actually use those to record voice annotations, and they get sent back up to the computer. And I'll just lean over here. You could probably hear it through my microphone. Anyway, we have a limited amount of resolution available here on the phone, but I'd like to be able to actually, you know, see that tooth when it came out. So I can pick sort of an area of interest here, and then you'll see first a dynamic zoom happens on the phone, and then it goes back and it retrieves the higher resolution portion of the image that's cropped down. So sending really a minimal amount of information, as little information to the phone as possible to actually enable the scenario. That's a little hard to read, but it's showing some of the metadata associated with this particular photo. It's marked as one of my favorites, and it shows the date that it was taken. And what I can do is I can select one of these pieces of metadata and say find related. And there's the server application running on the home computer actually maintains a database, and it's a searchable database. So I can find related items based on metadata. I can search. Maybe I'm looking for something a little bit more specific, like Halloween pictures, for example. So I can say browse by keyword. And I think the first time I do this, it takes a couple of seconds to load the list. But basically, there's keywords associated with this collection. They're primarily derived from the directory names. I'm not really good at organizing my photos in advance. About the most rich amount of annotation that exists is that occasionally when I would upload photos, I would actually put them in a directory with a meaningful name like Halloween or something like that. So in this case, we leverage those existing annotations. If you've actually embedded keywords in your photographs, using some of the commercial applications that let you do that, we'll also extract those and use those as searchable items as well. Or you can actually add annotations right from the phone here as well. It's got a text entry mechanism. So in addition to recording voice annotations, you could add text annotations that are then searchable on the photos. So I can very easily find a photo if I sort of know the name of the directory it's stored in or the keywords that are associated with it. We have other mechanisms of searching as well. Maybe I don't really know the name of a keyword that I'm looking for, but I might recognize some of the photos that were taken as part of the set. And this is showing basically the same list of keywords, except there's a representative photo for each one. Like I might want to find that pictures of when my friends and I took a motorcycle trip up to Canada, and it has a pretty meaningless keyword name because we took that trip several years ago before I started this project, and it didn't really occur to me to have a nice spelled out name. So it just says like BC MC trip. But I recognize the two guys in the picture. One of them is wearing a blue, riding suit, so it's obvious to me what that set represents. So I can easily get to things that way as well. And of course, digital photos have dates on them, so you can very easily search through things by date. If you know the specific date that something was taken, you could actually enter that in, or I might just want to see sort of a month-by-month summary. And that's pretty hard to read, but the different titles under there are telling me a month and a year, and I can sort of page through things about a year at a time. Like that's May of this year, and it'll quickly bring back pictures that were taken in that month. We also have the ability to, this is a camera phone, so any photos that I take with it, typically it's a challenge when you take pictures with a camera phone to get the photos out of the phone. Most of the carriers want to charge you in order to actually extract your photos, some sort of a fee, or they want you to go through their service or something. They are not that thrilled with the tying it to a particular PC. But we take advantage of the same data connection here with the fact that I'm connected up to my home computer is where all my photos are. And if I've taken any pictures with the camera phone, the application will just ask me, I've detected new photos. Do you want to upload them to your PC? And they just automatically transit to the PC in the background while the phone is in your pocket or something like that. And they're available for you to do things with besides viewing them on the phone. I'll show you some of the other scenarios that are enabled by this. I'm going to go back to my favorites here. And let's say I wanted to share one of these pictures of my son with his grandparents. There's a couple of ways I can do this. One is by email. They have a computer and they're connected, and I can say basically send this photo by email, and I'll get a not very attractive form here. But what this allows me to do is basically pick one of my contacts. Excuse me. And it'll just fill in their email address. And I can choose the size of the image, and I can, if I want to, I can actually poke in a little text message here, or I can record a voice annotation just for this particular email message. And then I'll hit send on this, and what happens is it doesn't originate the mail from the phone. It just instructs my home computer to actually package up an email and attach the photo, attach the voice annotation if I've recorded one, and sends it over my home computer's broadband connection. So I could send the original 5-megapixel image, and it would really only take a couple of seconds. Whereas transmitting that over the phone would take, half an hour or something like that. So it allows me to share photos via email in a very straightforward way. I could even be, out on vacation taking photos with the phone and then have them be annotated and emailed immediately before I even get home. We have a couple other viewing scenarios with these that I don't have another PC to demonstrate this, but we have, in addition to the telephone client for this particular database, we have a PC-based client that basically gives you some of the same sort of navigation capabilities and browsing capabilities, but it also has the ability to be like a standalone slideshow. And it connects up over whatever network connection you have for the PC to the internet back to my home computer. And I can, from a different location with the phone, because they're both connected up essentially through to the same photo library, I can remotely drive a slideshow on my phone. I could drive it from the phone, and I can control what photos are being seen on that PC, along with the voice annotations and whatnot. So my parents live in Arizona, but I can actually be driving them through a slideshow from right here in this room if I wanted to of new photos of their grandson. And, we could do panning and zooming and adding of annotations and all that sort of thing. But that's pretty much the end of the demonstration. Okay, thank you very much.
Great, thanks, Steve. So one of the cool things about that app, of course, is that it takes advantage of all the goodness of a full-fidelity PC somewhere on the network and lets you be able to use the mobility of a phone. So to sort of tie these things together, obviously we've seen a wide variety of different applications that leverage the power of the PC, but also take advantage of the growing trend of devices. And to pull the pieces together, we've invited Professor Brad Myers from Carnegie Mellon University. Now, in previous faculty summits, you might have seen some of the work that he and his team had done about distributed computing across mobile devices, pocket PCs, and PCs and notebooks. So this session is going to paint some broad brush strokes about what are the future research challenges in this increasingly divergent computing landscape. Thanks, Brett.
Thanks, Tom. So John gave me this kind of clunky title. I probably would have come up with something a little shorter, but it does represent what he asked me to talk about. In the past, as John said, I've presented the Pebbles project, and I didn't want to spend much time going through it, but there may be some people here who haven't heard about it, so I wanted to give you a quick overview. We've been working on handheld devices since around '97, and the presentations here over the last 3 years and demos and things. But if you're interested in more information, you can download a lot of these apps and see a lot of papers from our website. Three of the particular applications that we built quite a while ago was the remote commander application that lets you use your handheld device as the text input and mouse input for your PC, and also to see the screens. And of course, you can draw on it, and it's useful for multiple people if you want to scribble on your slides or check on things, that kind of stuff. All makes that very easy. We have a shortcutter program down here that lets you draw panels of controls on your Pocket PC to control your PC applications. You can, Visual Basic style, create any kind of panel you want and use it to pretty much do anything you want for your PC applications. And then the application I'm using now that you might have seen John using yesterday is this slideshow commander application that lets you use your handheld as a remote control for PowerPoint. I'm seeing on my handheld the slide that you're seeing and a little notes area at the bottom. I can preview next slides and previous slides, switch to demos, and do all sorts of other controls that are somewhat clunky to do if you don't have these kind of devices available. We have another project that's been going on for quite a while called the Personal Universal Controller, or PUC, which is a project to look at how these kinds of devices can be used as remote controls for all the appliances, all the electronic devices in your life. And the goal is to try and give you a nice, consistent interface across all your appliances so that every time you walk up to a copier, you get a consistent interface. Every time you have to deal with a VCR, you know how to use it because it's just like all the other VCRs that you've ever used. And this is actually a fairly difficult research challenge, the consistency part. To do that automatically, we're taking this high-level description of your interface, of your appliance, and from that trying to generate these consistent interfaces. And we're doing this both on the phone and on Pocket PC kind of devices so that you get this interesting issue of how to represent the same kind of interfaces on these fairly different kinds of devices. And we've done fairly simple applications like lights, medium complexity applications like stereos, and really complex things like the navigation system on an automobile, which if you're ever trying to use one, has 50 to 100 different screens, all kinds of information, different kinds of text entry, and all sorts of complexity. And then the final piece of research we're doing on this is looking at combining multiple appliances automatically. So in a lot of cases, you have this whole system of appliances, like for your home stereo system. How can we automatically combine all of those interfaces together into a seamless task-based interface that lets you do things in a nice, simple way? But I'm not really supposed to talk about those today. I'm supposed to talk about the future. And so I was looking around to see if I could find some examples of futuristic handheld devices. Surprisingly few in science fiction handheld devices. And Star Trek, has the tricorder and the medical scanner, but mostly what you find are weapons. So if anybody knows of any science fiction with good handheld devices, especially if you can find a picture, let me know so I can add them to my slides. So I just came up with, in some sense, kind of an eclectic collection of observations and research challenges that deal with the future of handheld devices, especially as they interact with other things. I think one of the key challenges that we all face is data integration. The user never wants to enter any piece of information more than once. Okay? If you have something as short as a phone number, something as big as a document, you never should have to type it more than once. And so the question is how to make sure that the data you enter into one device also appears in every other device that's part of your life. And we've got this level of connectivity now that there's no reason that that shouldn't happen. So this is connected to my laptop through Bluetooth. My laptop is connected to the world through the internet. There's no reason why all these devices should ever need multiple entry. And one of the ways we're looking at that, for example, is cut and paste. If you wanted to have a phone number in 2 different applications, you'd probably do it by copy and paste in your PC. Why can't we have something that simple between appliances? Or why should you have to do it at all? It should just know how to transfer this information back and forth. And using intelligence and other kind of AI techniques, it can do the transformation of data that's needed often. It's another thing we're looking at. If you need the same data in a different format, you still shouldn't have to retype it. It should be able to convert it automatically. Another issue that's very closely related is, well, where do I want that data to be? Okay, storage is basically free. You can get gigabytes on a little device like this, so you certainly can put most of your information in each place, but then you have the synchronization problem. You could put it all on the network, but then you're worried about security and where is the data. Suppose I get disconnected. How do I get to it? Maybe somebody will steal it or corrupt it. And maybe if I do have it all locally, then I'll lose this device, which happens on a fairly regular basis, and then somebody else will be able to access it. So how do I prevent that without making it so hard for me that I never want to put anything in here because it's just too much of a hassle? And then I know back at CMU we have a fairly sophisticated file sharing mechanism, and I'm sure where most of you guys are, you do as well, and yet we're still emailing documents back and forth all the time because it's just too much trouble to share them any other way. And then you end up with synchronization problems and multiple versions, and how do you control that? How can we make it so that all this data is shared in such a simple and easy way? It goes back to this data integration problem, so that we don't feel like we want to email documents back and forth, so that we can just email the pointer like we'd really like to do and have it all work in a seamless way. And once you have all this data that's shared across all these devices, you immediately want to be able to, of course, look at the data, and that brings up the issue of application integration. How do we get so that if you're, have built some application, some data in Word, and you want to look at it on your watch or on your PDA, can you open it? Do we need to have different versions separately implemented by separate groups, like Pocket Word versus Real Word, with some annoying inconsistencies and different ways of interacting? Or is there some way of taking the same kind of application, the same kind of interaction techniques, and modifying them in some seamless way across the different platforms? And of course, if we had better techniques for doing this kind of transformation, then we could think about innovating more with different kinds of hardware, because we could have this adaptation to different I/O devices that are available. One of the things that I think is pretty interesting is that if you look at the cell phones that have cameras on them and think about typing some text, it's actually easier on the phone to take a picture than it is to type something. Okay? But on the other hand, if you want to use that picture in something, then it's another 37 steps. It's really a pain. Okay. Can we make it so that the really rich media types that we're now enabling from these kind of devices, with phones, with speech entry, with talking to these things, voice recording, can we make those so that those work just as easily in all the different places that we currently put text? Obviously, with a laptop, it's a lot easier to type than it is to do anything else, and so text is really the natural mode of entry for laptops, but it really isn't anymore for these other devices. For tablet PCs, inking is much more natural, and it's really annoying that most of the time you have to convert that into text and then do error correction and things like that in order to make it useful. So how can we get all this rich data to be seamlessly replaceable for each other? Another thing that's related to that is, how can we make it so that you can enter less data? Okay, these devices know a lot more about us than they're making use of. If we're being asked a question, maybe the device knows the answer because of our context, where we are, what's in our calendar, our position, all the other kinds of sensors that it has. How can we use that, or a history of things we've entered in the past? We should be able to use this information in an intelligent way in order to reduce the number of times we have to enter text, predict what the user is going to answer, and give those as choices that he can select in some easy way. Another thing that many people have already worked on, including our group and Jeff Pierce's group, I think he talked about this, certainly it's on his poster out in the hallway, is the idea of using other devices when they're available, okay, so that you have your handheld, but we also have a really big screen. I have 2 keyboards in front of me and a whole bunch of mice. Why are these all so separate? How can we make it so that whatever environment I'm in, I can use whatever resources are there as a way of interacting with whatever data that I'm interested in? So if I have a need of a touch screen or a voice recorder or a phone for my PC, I should just be able to use the one that's on my handheld. And similarly, if I want to put something into my handheld and I've got a keyboard in front of me, all these should just work seamlessly and without a lot of changing. Jeff calls this opportunistic annexing, which is too hard for me to say, so I would probably pick a different word. But I think the really interesting research issues are the user interface ones. Of course, there are systems ones of how you get all these to interact, but they're user interface ones of which one is the best one to use. If we've got all these devices around in front of you, where are we going to put the output that the user sees? And where are we going to let the user do the control? How are we going to divvy up these different options amongst all the things that are in the user space? And does the user just get to pick? Do they have to pick? Or can the system be intelligent and know the right way to present a certain piece of information, the right way to enable a certain control? They're basic human sizes, and a lot of devices really have been optimized for those sizes. You have hand-sized devices or palm-sized devices that fit in your hand, and that's, the phone and the PDAs. And there's a real push to make those smaller and lighter and easier to carry. There are also ARM-sized devices, which is basically your tablet PC. It's really basically the size of your forearm. There's not really any big mystery why that would happen. If it's bigger than your forearm, it gets really hard to carry. And you've got your wrist devices, and then, of course, there's other devices that really are best used on the tables. I think, the clamshell Windows CE devices were fairly unsuccessful. I think there aren't any being sold currently. But it'd be interesting to see, there's this new generation of mini PCs. Yesterday, somebody demonstrated the OQO, or OQO. The one I'm showing here is the Flipstart, which I think is a Paul Allen company. So there's, a growing interest in, redeveloping this niche and seeing if it works. So that'll be interesting to see how that comes out. And then you've got wearables, which are, things you strap on, and other people have talked about these, things that connect to your eyeglasses, all sorts of things that are actually attached to your body. In the demo area, there's a sensor for sleep apnea. Okay, all sorts of different things that are enabled by having it actually connected to you. And there are, the usual trade-offs of portability, battery life, screen size. For readability, you want a big screen, and for battery life and other reasons, portability, you want a really small screen. So there's always these trade-offs. Another really interesting thing that I've observed is this really big tension between special purpose devices and convergent devices. We've got all sorts of little things that you sometimes carry around. You've got your mobile game device. So I've shown, I guess, a Nintendo here. You've got your PDA, a phone, a pager, a still camera, video camera, a music player, movie players, a watch, flash memory cards. And I have at least one of each of these. How many people do not have one of each of those? Okay. So a couple people don't have at least one of those. How many people certainly have at least one of every one of these? How many people didn't hear the question? So most people have, a whole bunch of these things, and sometimes you bring them along and sometimes you don't. And, Star Trek also had this concept of having special purpose devices, so the vision of science fiction writers isn't necessarily that there's going to be convergence. And there was also attempts at convergence like this is a Nokia N-Gage, which is a game and a phone, a game player and a phone, fairly unsuccessful product, I think. And this, of course, is our favorite Pocket PC, email device, phone, which are, in some sense, convergent devices, trying to do everything for you. It has a camera, it has video camera, still camera. So which one is, which model is going to succeed? I think it's inevitable that they'll all be available in the future, and we're going to have to deal with the fact that there's going to be different preferences for different people. It's a big world, and people have different preferences and different desires for what they want. And I think the big issue is, if we have this diversity of needs and diversity of designs, how are we going to get people to do content for our devices? One of the great things about the PC environment is that you can write your application and you know it's going to run in hundreds of millions of places. How are we going to still get that? We've been doing research on phones, and you've already got this problem that you can't implement it on the Microsoft phones and have it work on the Nokia phones. There's Symbian. There's all these different competing environments. Can we get to a situation where you can regain this portability? Of course, with game devices, it gets even more problematic of whether you're going to get other people to write content for your device. And we've got the basic HCI problem that what's good for one kind of application is not necessarily good for another application. So a good game control device doesn't necessarily make a good phone, which is one of the reasons that the N-Gage is not a particularly good device. People don't want to look like they're holding a taco to their ear. And but I think even if we go the multiple devices route, we should still be striving for this enter once principle, so that if we have these 10 devices around us, they should all still be talking to each other. So the phone, if you have a separate digital camera device, there's no reason it shouldn't be talking to your PDA device to find out where you are in order to annotate your slides automatically. If you have a separate watch that's, a spot watch that's communicating anyway, it can use that information in order to inform the other kinds of things that are happening in your life or things like that. So that I think there's, even if we get to the situation where we've got a lot of special purpose devices and they're spread all around, we still want the situation that if you enter it in one device, the other devices know about it. And another really interesting issue is we used to be in a situation where you just expected to find a phone everywhere you went, and now we've gotten into a situation where you just bring one with you all the time. And I think the same thing you might imagine with all sorts of other technology. You don't carry a stapler around, you're pretty sure you'll find one someplace. But what about, paper? Come to a conference, they're likely to give you a pad of paper. Can you imagine a future where this is true with technology kinds of things, that you bring your little memory stick and you can find, a computer in the room, and you don't have to bring a computer because you can just bring your data? Well, that's pretty much already happened. What about everything else that you want to do? If you want to bring a demo like I'm doing here, now I felt like I had to bring my laptop. How far can we get into this concept that you just bring, you just find the stuff where you go as opposed to having to bring it with you? And which is the right way that people want to go? And then another really interesting thing that's happening is all the pieces are becoming separated, right? You can buy these little separate Bluetooth earphones. I've seen a few people around wearing them that communicate with the phone while it's in your pocket. If we've got this cheap networking that's going on anyway, then we don't have to have one device that does it all. We can have all the pieces taken all apart. So you can buy a game controller, maybe that's just an input device, and you just put your Pocket PC phone as the screen, okay? And it has, game buttons on it or something like that, so that you can take the control pieces, you can take the memory pieces, you can take the I/O pieces and separate them out into special purpose devices that maybe you buy separately, but they'll still all connect together and still let you get the data that you need and have it all integrated. And that's something of the idea of the Intel Personal Server project, which was basically to put the memory and the processor on a device and leave all the I/O off to do separately. And there are lots of other research areas that I really didn't have time to cover, but I think are important. One of the things I really liked about John Sangiovanni's project from yesterday, Launch Tile, was it really was rethinking what the user interface should be like on a handheld device. It wasn't just taking desktop user interfaces and shrinking them. And I think, gestural devices, gestural interaction, finger interaction is very different than mouse interaction. The WIMP paradigm that we use on the desktop was invented 20 years ago specifically for a mouse and a particular size screen. It doesn't make sense necessarily to be just using that without much thought on little devices. A lot of interesting work needs to be done and thinking about what the interaction style, the whole methodology, the whole metaphor should be when you have multiple devices that are all these interesting sizes. I think there's a lot more that can be done with cameras, and people are looking at how do we tell where we are, where we look around. Cameras, might be able to do a better job of this than GPS and other kinds of technologies we're using now. They can be used for games, all sorts of different uses besides just taking pictures. They can be used for mousing and all sorts of things. We shouldn't forget people who are handicapped, who need to use our devices as well. And there's a lot of interesting aspects of the research on how we can make all the things we're doing not leave the handicapped people behind. Solis talked about the digital inclusion. There's basically billions of people in the world who have cell phones who don't have PCs, and how can we make it so that they can take advantage of the cell phones as a way of interacting with technology, of having technology available to them. And then, the HCI people always say security at the end and hope somebody else will deal with the problem. But, anything that's going over these networks has to be done in a way that's going to make us comfortable that people won't be stealing it. People won't be able to make use of our data in ways that we don't approve. So in summary, I think there's still lots of really important and interesting research topics in the handheld area. Our challenge is to make it so that these devices are not just another complicated thing you have to learn, but instead a way of making everything that users do easier than it would have been if they didn't have one of these devices. So how can we make this an improvement rather than something that makes things actually worse? And just as a final chart, there's about 6.5 billion people in the world. 1.5 billion of them have cell phones. About 500 million have PCs, although I have seen different numbers there. But when you look at the PDA numbers and the tablet PC numbers, they're really, really small compared to these other numbers. So it's a really tremendous opportunity here to think about how we can get some of these ideas, how we can, some of these services, some of these user interface techniques into many more people, and so that it can help a lot more situations. Thanks.
Great, thanks, Brad. So now I'll invite Steve and Zhenwang back on stage to take some questions. We have about 5 minutes for Q&A for those of you who might have questions in this domain. Sensory overload after the end of 2 days. You're like, just put me back on a boat somewhere. Yes, Sumi.
I have a question. I got out of the room for about 15 minutes, so I'm not sure if maybe you already presented. But I'm looking for an app that I really want to use that relates to what Steve have shown, which is connecting the phone to the PC. Sometimes it's too difficult to get them browse and go through the information I need on my phone. I would love to get the phone interface with the PC and maybe to edit things and move around much easier.
You'd like to interact with your PC using a phone interface?
No, I would like to interact with my phone using my PC instead of using the keypad.
Oh, I see. Like use your PC to type, for example, names and phone numbers. Yeah, I think that's a pretty good idea. It's pretty hard to do data entry on a phone for sure, and it really doesn't have anything like a mouse or anything like that at all. So I think that for the basic information that's used in the phone, for the most part, I don't do data entry on my phone, although I have a pretty substantial contact list and things like that. Certainly, email is a real challenge. Reading works okay, but responding is pretty slow. But the individual application sort of synchronization has, I think, kind of solved it for things like contacts and whatnot, and to a certain extent, calendaring. But John's got some pretty interesting ideas on input devices, I think, for phones, and maybe he can add to that.
Well, I think in general, actually, I think that you hit it on the head that that synchronization is big, right? So I think that model of interacting with the device, and then just sort of trusting and knowing that something magical is going to happen in the air and that the content's going to trickle down to your device. That's a key concept. You know, the concept of the U pen, where you sketch something and you just sort of know that it's going to end up back on your PC. I think that kind of vision is very pervasive. So that if you're sitting at a terminal, you input text quickly, or for that matter, if you're sitting at a public web terminal, you can input content quickly, and the information trickles back down to your device in a reliable way.
Yeah, from a purely practical perspective, if you find yourself needing to do a lot of text entry on your phone, I know that there are Bluetooth keyboards available that are very compact and that would interface with the phone pretty well.
There's also a great Microsoft power toy called CER Disp. If you just type CER Disp into your favorite search engine, it's this cool little free power toy that just lets you see your Pocket PC or phone device on your desktop. And then, so if you need to do some type of data entry on an application that only lives on the phone, that's another thing to use. And also great for doing presentations on a projector. CERDISP.exe. It's a power toy. It's on the Microsoft site. So do an integral search for Microsoft.com.
And there's another product available at Handango called